Hello, this is Scholar Strife. Today in Algebra 1, we're going to be looking at exponential decay. Exponential decay are very similar to growth, exponential growth equations. If you see on the left, we have an exponential growth where it increases from left to right. Exponential decay decreases from left to right. So it just looks like a reflection or a mirror, if you want to think of it that way. Mirror image. So let's look at an example here. So, 1/5. So if I'm going right to left, it looks like everything's being multiplied by 5, but that means we're dividing by 5, or we're multiplying by 1/5, by 1/5, by 1/5. So that's our pattern. So we have y equals a to the 1/5 of x. Just like in last section, we're going to choose a point that's easy to work with. We're going to use 0, 1. So 1 equals a times 1 to the, or 1 over 5 to the 0th power. So a equals 1. So my function is y equals 1/5 to the x. So make a table. So if we have two graphs, so we're going to make a table for both. So let's start off with y equals 1/3 to the x. If I plug in -2, so let's see what that looks like. 1/3 to the -2. Okay, that'll be, since we're dealing with a negative exponent, we flip things around and we get 3 to the +2. So that's 9. 1/3 to the -1 is 3 to the +1, so 3. Anything to the 0th power is 1. And then we'll get 1/3 and 1/9. Okay, and then our function here, they just want us to multiply everything by 2. So 18, 9, 2, 1/9, or 1/6, and 1/18. And then we're going to go ahead and graph. So I'm going to make this one black. So this is, and we'll make the other one red. But let's start off with the black one. -2, 9. -1, 3. 0, 1, or, yep, 0, 1. 1, 1/3. And 2, 1/6. So this is what my graph looks like. And if I do the red one, just everything would be kind of doubled. So yes, this is doubled. So this would be 2/3 and 2/9. -1, 9. Man, I messed up. This is 18, this is 6. There we go. There we go. And this is like super high up. So what's going on is that the red line is decreasing faster. So the y equals 2 times 1/3 to the x is decreasing faster then the y equals 1/3 to the x. This is a vertical stretch. Alright, let us graph some more. So this is going to be the blue one. X, y, -2, -1, 0, 1, 2. So instead of, we're going to take these numbers here, because we still have 1/3 to the x, but instead of multiplying it by +2, we're going to multiply it by -2. So I'll get -18, -6, -2, -2/3, and -2/9. So just like last time, it'll just be flipped over the x-axis. This is a reflection. So -2, 18, -1, 6, 0, 2, and then super small for these guys. Write a rule for this function. So they only give us 2 points here. Okay. So they give us 0, 5 and 1, 1. So how are we supposed to make y equals ab to the x function? Okay. So first we ask ourselves, it's decreasing from left to right, so this is going to be exponential decay. And how do we get from 5 to 1? We take 1/5, so b is 1/5. Okay, and now we're going to use a point. Let's go ahead and use 0, 5, and then plug it in for x and y. So 5 equals a, which we're trying to look for, times b, which is 1/5, to the x, which is 0. So a equals 5. So my equation is y equals 5 times 1/5 to the x. So the graph of an exponential function passes through the points 0, 4, and 110. So we have 0, 4, 110. Write a rule for the function. So how do we get from 4 to 10? So one way to write this is make a table. So we have 0, 4, 1, 10. How do we get from here to here? We multiply by 2.5. So you can find that out by doing 10 divided by 4. So our b value is 2.5. So y equals a times 2.5 to the x. And then we're going to choose a point, choosing 0, 4. So 4 equals a times 2.5 to the 0. So anything to the 0th power is 1, so a is 4. So my equation is y equals 4 times 2.5 to the x. The population of a city decreased from 1995 to 2003 by 1.5% annually. So when we see that word there, annually, that is 0.15 point. So we take that 1.5 as a percent and we move it 2 decimal places. So we get 0.105 for my r. In 1995, there were about 357,000 people living in the city. Write a function that models the city's population since 1995. So we have a formula. Y equals a times 1 plus r to the t. But since we know that they're decreasing, we're not going to do plus r, but minus r. If they were increasing, then we would add. So A is the original amount, 357,000 people in 1995. Okay, so our equation is y equals 357,000 times the quantity, 1 minus 0.015 to the t. So that would be our equation. Okay, and now they want to find the population in 2003. Okay, so 2003, so how many years was it from 2003? That would be 1995 to 2003, that would be 8 years. So t is 8. So we plug in everything we know. Y equals 357,000 times 0.985, that's 1 minus 0.015, to the 8. Plug it in your calculator, and you'll get, so 0.985 to the 8, and then times that by 357,000, and we will get 316,342 people. And this is approximately. In example 4, suppose that the decay rate of the city's population remains the same beyond 2020. What will the population be in 2020? So t would be now 25. So we would just use the same formula, y equals 357,000 times 0.985 to the 25th. So the population would have been, if the decay rate stayed the same, 244,666. Hopefully this helps you out. Have a good day.